In Prreview Activity 1.8, we're given the function g of x equals negative x squared plus 3x plus 2. And here's the plot of our curve. It's a parabola opening downwards. And first thing we're asked to do is find the derivative using the limit definition. Well, we've had plenty of practice at that up till now, so if you need more practice at that, make sure you go back and try it. But I'm just going to give the derivative for the sake of this video, which is minus 2x plus 3. In B, we're asked to use this to determine the slope of the tangent line at 2. So right here, we're trying to figure the slope of that tangent line. What is the slope of our curve at that point? Well, that's exactly what the derivative does. G prime of 2 is going to give us that slope. So plugging 2 in, negative 2 times 2 is negative 4, plus 3 is negative 1. That's the slope of our tangent line. Negative 1 makes sense because, as we can see, it's decreasing, and if you look and we tried to estimate that, it looks like it's going down 1 for every 1 we're going over. So it looks like we have a rise over run of negative 1. Now, in order to compute a tangent line, we need to know what this point is. We know that the x value is 2. We need the y value. Well, we can kind of see it from the graph there. It's 4. But let's verify it by plugging it into our function. So calculating g of 2, so you're going to have negative 4 plus 6 is 2 plus 2 is 4. And so we now are looking for our tangent line, which is a linear function, which you guys have found plenty of times up till now, with a slope of negative 1, and it goes through the point 2, 4. So let's do point slope form. So y minus 4 equals negative 1 times x minus 2. And there's our tangent line. Now another way we'll see it written is y equals negative 1 times x minus 2 plus 4. The advantage of writing it like this is once we have it y equals, we can graph it in a graphing calculator or some other plotting system very easily. Not all plotting systems will take this form. If we wanted to, we could also rewrite this in slope-intercept form. So we'd have negative x, so it still has a slope of negative 1, and distributing this negative 1 would give us a plus 2 plus 4, so plus 6. So that's another way of looking at it. So it would have a y-intercept of 6 here. And now let's go ahead and put in our tangent line. So we're going to connect those points, and it actually works out really nice because of that slope of negative 1. And there's our tangent to our curve. So there's our tangent line, y equals, in whichever form you prefer. I'm just going to use the slope-intercept for right now. So there's our tangent line to our curve g of x at the point x equals 2. And those are all the pieces we need to find it.